All right, guys. Today's class is on given a verbal problem, right? Write the inequality for it, or if you're given a graph, also write the inequality equation for it. Okay, and so again, you remember we talked about this last Friday. You got to know the verbiage or the phrase that is associated with each of these inequality symbols. Okay, so make sure you know them. Okay. Now, when you get in the word problem, the first thing you want to do is one. You want to read through the entire problem and highlight keywords and information that will help you solve the problem. Identify your variables, uh, write the equation or inequality, and sometimes we'll ask you to solve or just help the equation. You can also justify your answer, right? So let's look at the first one. Now, number one. I missed number one. I think number one's on the same page here. Number one, we did this on Friday. Okay. And so again, if we look at it, run needs at least. And so at least we're looking at this the inequality greater than equal to. All right. So run needs at least $350. Yes, save $9. So that's going to be your initial value, your constant. And then he makes $7 an hour. That's your key phrase to tell you that's going to be your rates there. And so to set the equation now, we're going to use the inequality at least. It's going to be greater than or equal to. And of course, we put 350 on the right. And then my initial value is 90 plus the rate is going to be 7x. And so we want to solve for x. We want to isolate the variable x. So I'm going to minus 90 on both sides. Minus 90 on both sides. Draw my line. That becomes 0. And so I have 7x is greater than or equal to 350 minus 90. That's going to be 260. And so if I divide both sides by 7, divide by 7, divide by 7, that becomes 1. So x is greater than or equal to, and I think that is 37 points, which run it off. I think it's going to be 37, yeah. Uh, 3 7s, 21, and 5. I'm sorry, 30. 3 7s, 21, and 5. That's 50. 7 cents, 49. So roughly $37. It's 37 points and some decimals. So we're going to say roughly 37 hours, right, for that one, approximately. All right, so that's number one right there. Number two, Rachel wants to spend no more than. So what is the inequality of no more than $23? All right. If you look at your chart, right, no more than is going to be the inequality less than or equal to. All right. So no more than $23. I'll put my 23 right there. And let's see now. Well, let's talk about peanut butter and jelly. Peanut butter costs $5 per jar. $5 per jar, and jelly costs $4. And it tells you now let x equals the number of jars of peanut butter. All right, so x equals number of jars of peanut butter. Therefore, my rate is going to be for peanut butter is going to be 5x. I'm going to have 5x. Oops. All right, 5x plus for jelly, that is $4. Going to be plus 4y. That's your inequality right there. And the next one, a party planner is reserving rooms for a corporate event and less than 1,000, and she has less than and that's less than $1,800 spent on renting the space. Okay, I thought I missed something on the wording right there. As less than, so that's my key phrase. At less than 1,800 to spend. Sunrise room cost $100 per hour, and toilet room costs 190 per hour. And so we have our variables that are x equals the number of hours, and y equals the number of toilet hours reserved for room. So what is going to be our inequality? Well, if you look at the chart at less than, right, that's going to be your, give me some more space right here. So less than is going to be, all right, that's going to be less than $1,800 she has to spend. So that's our limit right there. And it tells you the rooms for the sunlight, the number of hours for the sunrise room is reserved. That's going to be X. And for that, the cost is $100. So we can have 100 times X plus the cost for the toilet room is 190, and that is Y. Okay. So that's your inequality right there. All right, guys. So that's, I mean, set up this equation is not hard. All you got to do is, the key is knowing what inequality, which one you're going to use. All right. So let's look at the next one. Here now, we're going to, here we're given graphs now, and we ask to write the equality. All right, so let's look at the first one now. Now, quick review. For these graphs, you're going to have dashed lines and solid line, right? A dashed line uh, means that you shade below the line. Uh, I'm sorry, a less than, it just means that the line is dashed, right? And you shade below the line. And then greater than means that you have a dashed line also, and you shade above the line. And so that's pretty kind of self-explanatory. If it's greater than, you shade above. If it's less than, you shade below the line, and it's a dashed line. If it's an equal sign now, right? That's going to be a solid line. Just think of it. The equal sign just makes it a solid line. The equal sign, and then again, if it's less than, you're going to shade below the line. If it's greater than, you're going to shade above the line. Okay. So the key here is now is to find the slope on the y-intercept. So let's look at this graph right here. And so we're going to try find the slope. Now I'm going to find 2 points. I'm going to use rise and run to find the slope. And so if I look at this graph right here, I'm going to pick this point right here, and I'm going to pick this one right here. Okay. And so my rise is going to be, that's 1, 2, 3. Okay. So this is -1 right here. And so 1, 2, 3. So my rise is going to be 3, and my run is going to be 1. So you remember how I show you this, right? If you rise and go to the left, your slope is going to be negative. So my rise is 3, my my run is 1, rise and run, and because I went to the left, it's going to be negative. So -3 is my slope. Now my y-intercept is -3. Right here is -3, so that's my y-intercept. Now if you look at the line, it's a solid line. It's a solid line, right? And we shade below the line. So that means that my inequality, right, is going to be less than or equal to. And so my equation now is going to be y, let's fill in the blanks now, and then my slope is -3 times x, and then my y-intercept is -3. Okay, see how we did that, right? Remember, we're using, this is a straight line, and so we're using slope intercept to write the equation. The only difference now is for the equal sign, we're using inequality. All right, let's look at number 5. Okay, number 5, let's see. What's my slope? Let's see. This is 1, 2, 3. So and then 1. So we're increasing by 1. So let's find 2 good points. I'm going to go with this point right here is 4, right here. on the x-axis, right? And then if I go up, I have 3 right here. So my rise is going to be 1. If you notice, if I go up 1, I go up right here. My rise is going to be 1. And then if I run, it's going to be 4. 1, 2, 3, 4. So rise over run is going to be 1 over 4. But because I ran to the left, right? Because I went to the left, my slope is going to be negative. My y-intercept in this case, the line across the y-axis at 3. So that's going to be 3 right there. The line is dash, and we shade above the line. So therefore, the inequality I'm going to use is, and you can verify with your chart, is going to be above. It's going to be greater than right there. And so my question is going to be y is greater than a negative 1/4 x plus 3. And then let's see on the next page. Ooh, okay. Wait a second. Oh, here we go. Next page. 6 and 7. Okay, let's see now. Let's look at this one. Okay, let's look at the units. This is 0, so everything's below the line, right? The x-axis. This is this is 1. That's 2. That's negative 3 right there. So let's use this point right here. This is negative 3 right there. And so this is 2. So this has to be 4. It has to be 4. So this right here is 4 on the x-axis. All right. All right. So let's see. Now I'm going to use this point right here. So I have my 2 points I'm going to use. Therefore, if you notice now, if I go up, right, I'm going to go up 1 because I'm going to go up 1, and then I'm going to run. This is 2. That's 4. I'm going to run 4 right there. 4 units. So I go up 1 over 4. So my slope is going to be 1 over 4, but because I went to the right, it's going to be positive. My y-intercept in this case is going to be negative 3 is my y-intercept. My line is dashed. That's a dashed line. And I shaped the area, the solution area is shaded above the line. And so my inequality is going to be y is greater than 1 over 4x minus 3. Okay. So what is I didn't say this before. So any points in the shaded area, it will make the equation true. It will be a solution. Any point over here in the shaded area is a solution to the equation. All right. And then number 7, I think that's the last one. Let's find my slope now. Okay. Let's see. If I pick 2 points, let's go with this one here, and let's go with this one here. So this is going to be, okay, this is going to be 2 on the x. If I go up, right, if I go up, I'm going up what? 1 unit, all right? And then if I go this way, I'm going 2 units. So it's going to be 1 over 2, and it's going to be negative 1 over 2. Negative 1 over 2 is my slope. My y-intercept is going to be negative 1. This is negative 1 right there. That's negative 1. The line is solid. I'm sorry. The line is solid, and we shade below the line. So I'm going to use the less than or equal to. I'll put my y there. My slope is negative, so negative 1/2 times x, and my y-intercept is negative 1. All right, so I think that was it. Okay, and so any points in this area is part of the solution for the graph. All right, guys, so that's today's lesson.